Evening, everyone. Today I'm going to take a class about basic machine learning. This topic is under data science. I'm Dr. Isam Hassan Mahmood. Completed my PhD in computer science and technology and master in software engineering and BSc in software engineering. So before starting this class, we have to know about actually what is machine learning. Machine learning is a branch of artificial intelligence. Actually, uh, machine learning is a concern with design and development of algorithm and techniques computer to learn. Actually, the main focus of machine learning is to extract information from, and we have to use different type of mathematical and statistics models or technique that features. And this area is data mining and statistics. Machine learning and data science is not a single measure. It's a multidisciplinary field. Actually, we can apply machine learning technique in different fields like biology, like economics, signal processing, or any major in engineering. If we apply machine learning technique in data science, in economics or biology, then we have to collect some data sets, or we have to consider data sets related to biology or economics, but we can apply different type of machine learning on that data set. So we can say data science and machine learning is not a single measure, it's a multidiscipline. We can apply machine learning topic or technique or method in different fields and solve the classification problem or any decisions of data sets. Actually, some concept uh, evolving in different scientific traditions, like a statistics interface. Actually, statistics come from the field of applied mathematics, and machine learning is a branch of intelligence and pattern recognition. Actually, this is a um, branch of computer science and focused processing, speech recognition, and data mining. We already familiar with data mining. It's the field of database engineering. If we want to apply data mining techniques on the data set, we have to collect the database um, data sets for our technique, and we have to apply different type of machine learning or data mining technique on that data set. Actually, pattern recognition is one kind of, is a also one kind of similar topic of machine learning. If we have a some image and we want to predict some special things from that image, we can apply different type of machine learning algorithm to predict or get some patterns from that image. So here is, I mentioned some research topic related to the artificial intelligence or data science. We can say the machine learning as well. Reinforcement learning, this is very new area in our science or in our computer science or in our modern technology. And second one is robotics, third one is natural language processing, fourth one is computer vision, and fifth one is recommendation system, sixth one internet of things. We are familiar with maybe robotics. There have some device, and in the inside of device we have some intelligence software, and the software can control that robot and give us feedback what we want. Actually, natural language processing is a another kind of intelligence applications, like a translator, voice translator. We can say this is the example of the natural language. And computer vision is related to the video processing. maybe we can collect some videos data or movie data or some webcam data and analysis or predict something from the data is one kind of computer vision, example of computer vision. And recommendation system we are very familiar with that, recommending some product or information to us or user. This is the example, like we are using Facebook and Facebook is suggesting some product like a watch or like a clothes to us, because maybe few hour or few days ago we visited or we searched something related to watch or clothes, and the Facebook suggesting us to some product to us. So internet of things, we already know about that, something device and internet connecting through and solve some intelligence problem. Because internet thing, we have some electronics device, and inside of electronics device have a intelligence. Inside of intelligence we can install some AI application on inside of device. Actually machine learning, we can apply our machine learning. I already informed you all guys that machine learning can be applied in different field, like a business, entertainment, medicine, software engineering, data and communication engineering, and computer security. Like business, actually maybe you have some question where this is business, but machine learning is related to computer science. How can we apply this in our in the business field? Actually business, from the business or client, lot of data set is generated every day and is stored in the database. Okay, so we can apply different type of data mining or machine learning or data science algorithm or technique to find the association between product and clients. Even we can classify or we can visualize data to our client or our industry owner. And entertainment, where we can apply our how we apply machine learning or data science application in entertainment. We can classify of music based on emotion or lyrics. And medicine also, machine learning can be applied in health sector as well. Actually if we have a patient data or any medical data set, we can classify the clinical pathology from our data set. Even we can apply machine learning algorithm or technique or models in software engineering to predict or measure the quality of software, cost of the cost predictions, or quality of software, size of software. Even machine learning can be applied in network system, like in the routing mechanism, link quality prediction in wireless sensor network anomaly detection as well. And computer security, yes, we can apply the machine learning algorithms or technique or in the computer security as well. And I gave the right side, you can see the some examples or applications where we already some example, like spam filtering, credit card fraud detection, digit recognition on check, zip code, detecting face image, MRI image analysis, recommendation system, search engine, hardware recognition. Actually all are example or real life example for machine learning. Like spam, I want to give and details about the spam filtering. Actually we are using email, and they have a one spam folder. Actually if our email is not very important and unnecessary, it automatically goes to the spam folder. Why it goes to that spam folder? The machine inside of the Gmail or other email address have a machine learning techniques. So that machine learning can predict this email is unnecessary, so it's sent to the spam folder. If the mail is very important and necessary and general mail, it goes to the um, it goes to the inbox. So even we can apply our machine learning algorithm or technique in credit card fraud detection, even digit recognitions, zip code detecting face image. Like if we are going to a shop, or if we want to go for very in security place, maybe our image will be captured from and detect our face as well. And there have a lot of application in the medicine. We can do MRI image analysis and predict the disease from our body as well.
Sir, I
That's
have
it.
a question.
Okay, sure.
Sir, I want to know more about machine learning in medicine. How can we apply machine learning in medicine sector?
Okay, very good question, because we already know that machine learning actually is related to the computer science or computer science background or electrical background, but for engineering sector. But how can actually apply the machine learning in medicine? This is very good question. Actually, actually the medicine actually is the chemical structure. Okay, we already know that chemical structure, so we can extract that chemical structure using different type of machine learning feature extraction method and generate the numerical value from that medicine, and we can analyze that numerical value and give the prediction using different type of machine learning algorithm, and we can suggest some drugs for any disease. So machine learning can be used in not only the health sector, we every sector we can apply this machine learning algorithm.
Excuse me, sir. Sir, our economy 80% is depend on textile sector. I completed my BSc
Okay,
in textile, so I interested to
very nice.
know how we could use this machine learning or data science in textile sector also.
Okay, I'm glad to hear that our one of students come from another department, textile department background, and he is very interested in data science. So he joined as a master student in our Daffodil International University, and he asked me one question related to the data science. How
Thank
can
you,
we
sir.
apply actually the textile engineering sector? Actually, textile engineering sector have also some data about the clothes. Maybe I don't know actually much about the parameters or some clothes parameter of clothes parameter, but clothes and machineries related to the textile engineering have a lot of information, like features, like one machine or on clothes have a lot of feature, color, weight, dimension, a lot of feature. We can consider that data set for our machine learning and predict or um, uh, uh, classify plus the clothes or predict using the clothes image, and give the decisions, some decisions what actually the client wants.
Thank you, sir.
Okay, actually, this is the basic about the machine learning. So I'm going through the full model, actually, how machine learning actually work, and what type of stage or what type of framework or what type of step we have to follow for starting to the ending. The first one is the data collections. Data collection is the very important part, because I already mentioned data can be text, data can be video, data can be audio, and data can be image. A lot of format can be image. So if we collect data sets from the reliable source, then reliable source and good format, then we can apply these data sets for the machine learning. But their second step is data preparations. This is also very important, because if we collect on a data set, and if inside of data set have maybe some missing value, or data set is not clear well for the for learning, so we have to apply some cleaning process or feature extraction method to make our dataset in appropriate format, because inside of dataset maybe some of information is missing, some information redundant feature, so we have to remove that features from our dataset and make our dataset in perfect shape. And third number is that they have some machine learning technique or data science technique to cluster or statistical technique we have to apply inside of datasets and make our dataset in for the learning phase. Like fourth phase is the machine learning, and we can do classification, or we can give the scoring or predict the scoring. We can predict the models, and we can estimation different type of parameters in this stage. And last one is the our predicted results or accuracy or performance, we can visualize, or even we can do some more experiment, or we can visualize our data from first stage to the result stage as well. And I right side I give on the draw one don't what on diagrams about the full process of the full process of our machine learning or data science in data science techniques. Like first one is the initialize. We can see there's the initialize a data sets, and we can do some the process for our data set. We can remove some data sets, we can clean our data sets, and this is the p process data sets. And data sets, maybe we need to extract some features. Like I already give one example. If our data sets is chemical data, and how can the machine will read that chemical data? Then no way. We have to apply different feature selection method to extract that chemical data to numerical data. Without numerical image data, our machine cannot be processed. So in this stage we can do some feature extraction method and make our data set in the numerical value. After that we can apply different type of like we can split our data sets, like a split in the training set and testing set. We can make it 80 to 20, it depend on us, and we can apply our different type of machine learning algorithm on the training data sets. Okay, like a SBM, random forest, decision tree. And then we can apply feature selection method if our we can see if our feature is very huge, and we think that our those feature is not important for our not for model. Then we can apply different type of feature selection method in our dataset, and we can remove some features from our dataset and make our dataset in a perfect shape. And then we can apply cross validations method, because we have different type of cross, like 5-fold or 10-fold cross validations. And here we can apply some we can consider some parameters like evaluation metric like MCC, specification, sensitivity, accuracy, or AUC, AUPR, different type of parameter we can find, we can generate, or we can predict from our model using our machine learning algorithm. Actually, this is the basic process for our machine learning, and we have to follow, or we have to follow all the steps if we want to train, or we have to classify, we have to predict something from any of data set, whatever is the video, whatever is image, whatever is text. So this is actually the basic process. Because why we'll apply the machine learning, maybe if our data set is very small, we can say, or we can predict from anything, or something from that data set is by calculating or see after see that data set. But if our data set is very petabyte or terabyte, then we cannot predict from data sets. We have to apply machine learning algorithm, because Facebook, YouTube, Twitter, and a lot of social medias are generating a lot of huge million billion information. So we need to actually visualize, we need to predict, or we need to classify some information from that information, and give some decisions to the company owner, and they can promote, and they can utilize our decisions, and they can promote, or they can utilize our decision, and plan for the next business plan. Actually, the first part of our machine learning was the data collections. Data collections, the goal of the data collection is main goal is the having good data, because without having good data we cannot process. Even our data set should be the balance. Without balanced data we cannot predict anything. Okay, because if our data set is imbalanced and having not good nature, then if we apply our machine learning technique or data science technique on that data set, we'll get the biased result, or the result will be not perfect actually what we want. Okay, so second step, feature extraction. You already I give the example that if our data set is related to the chemical, we have to extract, we have to apply some feature extraction method to make it numerical value. And another part is feature selection. And actually in this stage, actually the feature selection, if our feature is huge and very big, like 1,000 or 1,000 features, actually there have some feature we no need. So we can remove that features, and right side we can see a graph or diagram like a full features. Maybe we cross or remove some features, and then we get the final features. And the main goal of feature selection is remove some redundant feature, or and using the dimensional technique like a faster, make our process make our model train more faster, more interoperability, more reliable. Can give
I
you.
had a question.
Okay, sure.
So how can we extract features from the dataset?
Okay, it's actually thank you for your question. It's actually depend on which format is your data. Like maybe I already mentioned, data can be text, data can be chemical, data can be chemical structure, data can be video, um, data can be image as well. And like a image, maybe we can apply different type of feature selection method to make our data set to in one format to another format to make more reliable. Even I will already give one example. If our data set is like a human protein data set, okay, human protein data set can be maybe a b c d like this. Maybe you are, maybe some guys if from science background, they are already know that the protein sequence have maybe a b c d like this. So this type of data set actually machine cannot be predict from the data set. So we have to apply different type of machine learning, or we can apply different type of feature selection, sorry, feature extraction method to make these data sets to numerical value, or numerical like 1 2 3 4 or 0.345, this type of data sets. Then we can apply, or we can use this data set for our machine.
I got it. Thank you, sir.
Okay, and next slide.
Hello, sir.
Yes.
How to select the future and future selection, sir?
Okay, feature selection, right?
Mm.
Very good question. Actually, I already mentioned that if our data set have a lot of feature, okay, like huge feature, more than 1,000, actually some features should be, or some feature may be no need for our model training. It's unnecessary feature. So we can remove that feature from our data set. Maybe some feature may be redundant, some irrelevant. So we can delete that feature, because that feature will not help us to training our model. That feature will decrease our accuracy of model. Even that feature can causes for the biasness of our model as well. Okay, maybe we can go for the next slide. Like this stage is actually, I mentioned that the machine learning can be a different type of, like a supervised, unsupervised, or reinforcement learning, or semi-supervised. Okay, we can right side we can see a photo. Okay, the image, the machine learning may be unsupervised. Unsupervised is the two type, like a clustering or dimensional reduction, and supervised is the regression or classification, and another part is reinforcement learning. Actually, I will go through the reinforcement learning more details in the next slides, because reinforcement learning is a very new topic here. Okay, the clustering, we can see the right side of the clustering. Actually, k means clustering can be different type. K means clustering means shifting, k medullus, and another is dimensional reduction. You already familiar with all guys about the dimensional reduction. It's the PCA, can be PCA, feature selection, or feature reduction, or LDA. This is all our dimensional reduction. There have more dimensional reduction or feature selection method as well. And supervised is the regression model, decision tree, linear regression, logistic regression, all are the regression model as a unsupervised learning. And unsupervised, maybe SBM can be a unsupervised, even and naive Bayes and KNN is unsupervised supervised algorithm. And right side we can see, actually for supervised learning algorithm, our training data set is seen. Okay, and desired result is output is also seen. Actually, this is level is, and output level is already know the machine. So machine will learn from both of like training data set and desired result. And unsupervised algorithm, we just give the training data sets and without desired output result. And semi-supervised, the training data set is known and few of desired data set is also known. Reinforcement learning actually is not the training and data set is fully actually unknown, and we can get the reward from the sequence of actions. And I will more details in next slide about the reinforcement learning. Actually, I'm giving one basic examples about class supervised learning algorithms. And supervised learning algorithm, we can see the right side of our one image. We divided or classified two things. One is minus, another is plus. Maybe I give here is 5 image we can see, and they classify in 2 types and 3 types like this. And this is actually the supervised learning algorithm. The training data set and output of result, we already know about that. Machine learning know about that, and we already give the desired results to our machine or model. And supervised unsupervised actually is a discovering hidden pattern from the unlabeled data, because in unsupervised the unlabeled data is unlabeled, or predicted or target value is unlabeled. Okay. And combines both label and label example for generating appropriate function or classifier. Actually, this is the semi-supervised algorithm. Actually, I'm giving one examples for decision tree algorithm, and then maybe next class I will details more about the decision tree algorithm or others algorithm, kn, semi-supervised, XGBoost, AdaBoost, and lot of or even for the deep learning as well. This is I'm giving the one examples here. Maybe the data set is related to the defined type of animals, and our target value is which animal is yellow color and which animal is most height. So we apply a decision tree algorithms, and in these data sets. And first, the condition is prove that which one is yellow, is left side, and height is less than more than 10. Okay. Then left side is go to the tiger and giraffe, and right side the false. And then we apply another branch of technique. We can see the tiger is the less than 10 feet, so it's the false. And right side we can get the desired result as well. This is the just basic. Maybe we did this decision tree maybe in our bachelor, like if we done the algorithm, basic algorithm, even the data structure course, we get the some decision tree algorithms, and how the work, how this algorithm works, we already know or familiar with. If you have any question, maybe we can go for more details. Like this is very important topic. This is very important topic. This is deep learning or neural networks. Actually, deep learning is a new technique. It's come from the neural network. It's not a actually very new. Neural network is actually neural network. Uh, a neural network is a concept. The concept from of neural network come from the human brain actually. So deep learning is a subfield of machine learning, and concerned with algorithm inspired by the structure and function of the brain, calls artificial neural network. It teach a computer to filter inputs through a layer and learn how to predict and classify information. Actually, we can do some prediction, we can do classifications from using a deep learning concept. And deep learning is come from the artificial neural networks. Neural network is not a new algorithm, but concept of deep learning is new because we apply use a neural network. We design neural networks for our deep learning. And input can be different type of image, text, or sound, or video can be input in deep learning. Actually, we already know that in our brain a neuron has a body, dendroid, or axon. The signal from one neuron travel down the axon and the transfer or any information to dendroid to the neurons. Actually, this connection where the signal passes is called the snap. Actually, the neural our neural come from the human brain. Okay, we can get the input observation, and we can put into one layer, and we can right side we can see a picture, and the green input layer, and the maybe I don't know the color of this, maybe something blue, and the red is the hidden layer, and right is our red one is the output layer. So we have to remember in the deep learning algorithm we have a three layer: input layer, hidden layer, and output layer. So hidden layer can be many. It's depend on data set. Is depend on experiment design as well. Okay, so if we input our data sets in input layer, the hidden layer can process our data sets, and we get the desired results in the output layer. Anyone have a question about deep learning, or anyone have interest on deep learning? Okay, we are going to the next slide. Actually, deep learning have a some topic. Deep learning have also some related mechanism like back propagations, forward propagations, and deep for feed forward, action forward, and threshold function. Actually, if we apply the deep learning in each learner have a active function, the functions and to understand without the mathematical reason. Actually, in our machine learning algorithm, in our deep learning algorithm, there have a lot of mathematics inside of, but we can use some package to solve the to call our deep learning algorithms to predict something, or predict give decisions from any of data sets as well. This is information in reinforcement learning and their elements. Actually, this is our last slide. I'm going to this slide. This is very interesting topic, because this application we already know that there were some countries started to apply intelligence in their car. Actually, this is called the self-driving car. Okay, self-driving car, actually we no need to any driver. This car will learn something from environments. If our car is in on the road, uh, this car will learn and he will take decisions from the environment. For examples, if behind or in front of this car have a some gray red signal, the car will capture that image or video and analyzes that video using machine learning algorithms, and the car will automatically stop. When the green signal will start, the car will take the another video capture or image capture and analyze using machine learning technique or deep learning technique, and then reinforcement learning, and then give the decisions or give the instruction to the engines to go forward. Okay, actually here is some agent environment reward state action is working involving in. Actually, agent environment agents means that our car environments is the where this car is going. Reward means the instruction is state is also instruction, and action is also the take the actions. That means that the car will take capture the image from the environments and process that information using reinforcement learning algorithm and take action, give the instruction to our machines to go forward. So this is very interesting. Maybe some applications are coming to in economics, genetics. Even we can apply in genetics or biological sector in this topic, and even we can the game playing recently applying the enforcement learning. Thank you very much,
Sir, I have a
everyone.
question.
Okay, sure.
Sir, for machine learning, which programming language is best?
Okay, a very nice question, because machine learning actually we can two is very familiar or popular programming language. One is Python, another one is R. But I always prefer Python, because Python have a huge lot of package that we can use easily. and we can load that package in our environment, like Anaconda or another platform or another framework, and we can call that package and implement that package or apply that package in our data set, and we can get the desired result as well. So do you have any question, all guys?
Sir, I have another question from deep learning.
Okay,
Sir,
sure, please ask me.
which dataset is perfect for deep learning?
Okay, very nice question. Actually, there have a lot of algorithm you already know, maybe KNN or maybe SBM or maybe decision tree or logistic regression. There are a lot of algorithm, but actually for deep learning, which data set is perfect? Actually, deep learning is, I already mentioned, deep learning is come from the neural networks algorithm, and deep learning have, if our data set is huge, very big, then we can use a deep learning algorithm. Without very small data, we no need to apply deep learning. If you use the very small data in our deep learning algorithm, then our prediction result will be not good. Reinforcement learning or deep learning is, those techniques are for huge data set, not a for small data sets. Best data sets is if our data sets properties is very big, then we can apply deep learning techniques in our data sets. Without big data sets, it's better to not apply.
Okay,
Do you have any question? Okay, so maybe we can finish our class today. This class was just basic about the introduction. So next class will be more deep about the feature selection, balancing, and more deep about our defined type of algorithms. Thank you very much.
Thank you, sir.
Thank you, sir.
thank you, sir. Sir,